Okay, so this is the third problem in the grind 75. This one is called merge two sorted lists. We're given 20 minutes for this problem, so we're going to start now. Okay, so you are given the heads of two sorted linked lists, list 1 and list 2. Okay, they're sorted. Make sure I remember that. I want to merge the two lists in a one sorted list into a single sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. Okay, so I sort of have an idea, but let's look at some examples. So 1, 2, 4, 1, 3, 4. We should be splicing together the physical nodes. We should not be making copies. So this is destructive, this algorithm. And so we're going to go 1, 2, 4, 1, 3, 4. I see the first thing that comes to mind is that we would have two pointers. Um, we would also have some need to have some way of breaking ties. So, 1 and 1. Maybe we could just have list 1 go first. Empty lists, return an empty list. So both are empty, return an empty list. One is empty, just return the other list. Okay. So it seems pretty straightforward to me. I want to think of any weird cases. I might not even have to use the drawing pad for this. I know I'm going to be using two pointers. And let me just write some notes down. So for one, so 2 pointers. Let's see. Actually, just I'll just do that. Don't want to lose too much time. They're already sorted. We want to return the head of the merged linked list. So we're going to return a list node, and we should probably look at the methods that we're given. So each node contains a value and a next. Let's see. There's a couple list node constructors. So we can create a blank one with just a value, and then one with a value and a next node. Okay, that's a pretty straightforward. So the keywords are val and next. Let's see. So we're given two list nodes. Yeah. So do we need to have 3 checks for these cases? If both are empty, if one is empty, and if the other is empty, do we need to have 3 initial if checks for that? Or is there a more concise way of doing it? For now, I'm just going to say we're going to need both empty, one empty, other empty. Let's see. They're in non-decreasing order too. Okay. So yeah, other than the odd cases, let's think about what we'd actually be doing. We're going to start by putting a pointer on both lists, two different pointers, one for each list. We're going to compare the values. If one is less than the other, then we are going to, so say if say this is linked list A and this is linked list B, if A's node is less than B's node, then we will let's see. We'll simply create, so let's see, we're gonna have some sort of dummy node. We don't know whose head will be first. So I don't want to just check to see if our constructed linked list is null and then assign the head to that. Let's see if there's a better way of doing that. Let's see. So we're going to a pointer here. If the A node is less than the B node, then so there's going to be some third party, well, no. Should be made by splicing together the nodes of the first two lists. Okay, so let's see. So if we don't want to make a third list node, one that we can use to construct this entirely spliced together list, it seems like we can't make any of our own linked list nodes. We can only use what we're given. So cannot create linked list nodes. I would confirm this with my interview, but I'm pretty sure this is how this problem is set up. Okay. So say we have pointers here. Is A node less than B node? No. So then we would make B nodes next. Points to where our A marker currently is. And so that would be okay. But then we lose, if we change this next and have it point here, which I will actually switch over to that. If we have this next point here, we won't have a way to move on there. And if we move B's pointer over and then try to move the next, we can't do that either because we don't have access to it. So, I mean, are we going to need 2 pointers for each linked list potentially? I feel like that might be a little excessive and there's probably a more efficient way of doing it. So, I mean, we could have A current pointer and a B current pointer, an A next pointer and a B next pointer. But that seems a bit excessive. And my logic for that is we'd have both of them. So say we're just looking at B, we'd have the B current pointer and the B next pointer on the same value. Once we made the comparison between these two nodes, using my logic, this would be the head of the merged linked list. And so what we would do is we would take the B next pointer, move that over, assign the node that the B current pointer is pointing to. We would assign that to this value, and then we would assign the B current pointer equal to what the B next pointer is. And we will do this for as long as the current pointer is not null. And again, A will also have its own pointer. And okay, so 4 pointers, it's going to be well, since they're called list 1, list 2, I'll say list 1 cur, list 1 next, list 2 cur, list 1 next, and then we're just going to say, and let me actually switch over to the screen so we can see. Yeah, so again, the 4 pointers, and then if list 1 node is less than list 2 node, if that's the case, then we're going to move next, reassign cur equals next, and then we're probably going to do this for as long as cur is not null, and this could be either of them is null. So as soon as one is null, then we can just tack on the rest of the other list to the end of our currently made list. So I will write it out right now and see if we can clean up the code a bit later. So let's see. The first thing we're going to do is check for the different cases. So if list 1 equals null and list 2 equals null, so let's see. So if they were to short circuit, so if they were both null, then we could just return the list. We would just return new list node just like that with nothing. But I want to see if is there so short circuiting. So this was short circuit on the first false one, but we wouldn't be able to say if list 1 was actually full and this one was completely empty. It would short circuit on this one, but it would return I think it would return list 1 actually, if I'm remembering correctly. But I'm not going to worry about that right now. I'm just going to write everything out as in sort of a brute force manner. So return list 2 else return list 1. And we could do this iteratively or recursively, but I'm probably going to do this iteratively. If list 2 is equal to null. Okay, I'm certain there's a cleaner way of writing this, but we're just going to have this for now. And So actually we don't necessarily want to have the same checks. So I'm going to look into how we could do this recursively. Um, yeah. Okay. So yeah, let's see if we can do this recursively. So let's start out on 1. We have the heads of both. Um, so again, making this comparison, if list 1 dot val is less than list 2 dot val, which in this case it's not, but let's say it is, then we are going to, let's see, we're going to want to have that one be first. Also, we're going to be building a linked list, but if we do this recursively, how would we don't want to instantiate a linked list every time. We want to just build on an existing one. So okay, I'm actually going to start with the else case just because it actually aligns with the example that we've been looking at, which is the one over here. So in this case, the 1 isn't strictly less than the value from list 2, so we will make the value from list 2 that first node, and we will make its next the node from list 1. Um, so let's make it temporary actually. So I'll say list node temp is equal to list 2, and then we would say, let's just say list 2 equals list 2 dot next, and return temp dot next. Is that right? So first we'll say temp dot next is equal to a recursive call merge 2 lists on list 1 and list 2. I think that should be good. So then we would just do technically the opposite, equals what's list 1? List 1 is equal to list 1 dot next. And then we would say temp dot next is equal to merge 2 lists. That would be list 1 and list 2. Okay, so I haven't debugged this, but there's 20 seconds, or yeah, less than that now. So I'm just gonna run through it really quick and see if this would actually hold up, and then we're going to look at some examples. So let's just think about it. So we have these checks, both empty, one empty, the other empty. Um, we're going to say, let's just kind of run through this example. So if we have pointers to both right here, if this one is less than, yeah, so if the node from list 1 is less than the node from list 2, that's not actually the case, so we're going to go to the else case. We're going to make a temporary node out of the head, and then we're going to move the pointer for list 2 over, and then we're going to set the temps next equal to the merge, and then we should probably return temp dot next, or temp actually. We would want to return temp. That's right, return temp. Okay, so that would mean we would have moved to 3 here, and this would still be on 1. So in this case, 1 would be less than 3. Make a temp out of that, and move that on, and then temp dot next would be the merge, and we would return temp. So that would technically go back here, and 1's next would actually be that. So yeah, this seems to work to me. I will actually hit submit and see if that works. Oh, little compilation error. Let's see. I do not know why I use curly braces there. That's funny. Yeah, let's hit submit. Or compilation errors. Funny Java stuff. Semicolons. Some more semicolons I'm seeing. Missing. That's missing there. That's missing there. Okay, let's just go. Come on. Misspelled. Okay. This is quite funny. Okay. Input, output, expected. Okay, I'm going to stop the video here. So we weren't able to get through the problem. But I think we're sort of close. But I will have to stop.